Epiq's NDR504 40 gigahertz 4-channel downconverter has come out. This is a compact commercial off-the-shelf downconverter that is designed for high-frequency signals. Includes 4 independent channels with precise phase alignment and an upconverter for on-mission calibration. I mean, this is ideal for tasks like phase-coherent direction finding, signal and interception in airborne, land-based, and unmanned environments, which we know that's where what warfare is turning into, right? With a rugged aluminum chassis and a small size, it makes it suitable for installation near antenna apertures, which we've you see here. Compatible with various SDRs and tuners, this ensures seamless integration into existing systems, which I think is going to be the biggest piece, is integration. But I'll let you two chat about that. It supports the growing need for intercepting signals above 18 gigahertz, including Wave 5G and beyond. It's great. High tech in a small package.
This thing is designed for flexibility for installation near any antenna aperture on the ground, unmanned systems, airborne environments.
Yeah. So seamless integration.
Called it.
Is that where you're going, Andrew? Seamless integration?
It is. I mean, seamless integration of high frequency COTS tech, COTS tech in diverse platforms without compromising system performance or interoperability. It's integration every step of the way.
But once it's installed, once it's integrated, how do you maintain phase alignment and calibration in mission critical, harsh environments with conditions that are constantly changing? The operational challenges of maintaining this high precision in the airborne, the unmanned systems, I think might actually be more of a concern than just the installation and integration. You've got to have your precision and quality figured out.
Yeah, important, but it doesn't kind of matter if that tech can integrate seamlessly into the legacy or even multi-vendor systems that are out there. It's just going to end up being a fancy box that collects dust at the end of the day. So interoperability is key for adoption here. Without that smooth integration, even the most precise tech fails to deliver real world value. So particularly in these kind of mission critical applications that it's being used for.
But if it's integrated but isn't working correctly, it's also just going to collect dust. So there's only one way to get both of these goals accomplished. I think you have to figure out what it has to connect to, how it has to perform. The goal here is that they want it to work off the shelf, without a bunch of configuration stuff as well. So this one is really a whole bunch of looking at requirements.
Yep. And traceability and design and change, making sure that AI then is going to come in and predict how these designs will change, such as new antenna configurations or platform environments that will impact its performance and alignment.
And simulation and validation.
Yeah, exactly. You've got to simulate next, haven't you? Validate the whole thing, and then pushing that through into the whole manufacturing side of things. Make sure your process plans, your bill of process, pulling through that up-to-date design on a real-time AI basis, optimized for your manufacturing processes, and making sure your supply chain's integrated. So the critical thread. See you next week.